at NetApp SolidFire these days. So I'm in the storage world most days of the week, and a lot of the things that our customers are interested in is finding out how to bring, I guess, more and more customers into their cloud environment if they're running a public cloud, or if it's a private cloud, they maybe want to expand its use in their business. And the trickiest part for a lot of them is running all of their applications on a shared storage infrastructure and still actually having some level of storage predictability. So they don't want to have, unless it's a really low priority application, they don't want some kind of really important application running in their cloud and it works great most days of the week, but then all of a sudden maybe Friday comes along, everybody's using their cloud and storage performance kind of tanks that day, including the performance to their mission critical applications. So a lot of the work that I've been doing is bringing the quality of service features that SolidFire offers into the CloudStack environment. I've been with the CloudStack community for over 4 years now, and just sort of bringing feature by feature to each of the different hypervisors that CloudStack supports. For the most part, I've been focusing on KVM, VMware, and XenServer, and all of those hypervisors kind of have their own challenges around making use of this kind of a model of storage. So we can kind of get into that in a second. I don't want to take too long because I know we probably only have about 15 minutes. So let me go and do a little bit of a demo here, and just to sort of kind of show you what I'm talking about a little bit more concretely. And if you have questions along the way, just kind of yell them out. We can handle them as we go. So yeah, don't be shy. What we're seeing here is kind of theoretical 4.11. 4.10 isn't released yet. It's still kind of in the release candidate phase. We've unfortunately been there for about 3 or 4 months now, still trying to work out 4.10. So this is the next release beyond that. But a lot of these features actually still work in earlier versions. But I just want you to know this is 4.11. And we're going to quickly go over to the storage, primary storage area. And you can see here I've got a couple primary storages. This bottom one is just sort of standard NFS. So there I just created an NFS share as you're used to, and integrated that with CloudStack as primary storage. I don't know what kind of performance that share gets. If I put a bunch of virtual disks on it, I especially can't tell you what kind of performance each of those virtual disks is going to get. So I maybe wouldn't be as confident running my more mission critical applications on that particular primary storage. The one above it is kind of a more unique primary storage in a couple ways. The one is that it's actually scoped at the zone level. So it's not like the traditional primary storages in CloudStack, which are scoped at the cluster level. In this case, I'm actually targeting all of the clusters in the zone. And the way I do that here is by not pre-allocating any kind of a share or a volume. There's no pre-allocated volume on the storage cluster. What I've done here, you can see it in more detail if I go to add primary storage, and the way I set this up was I actually picked zone-wide, although cluster-wide does work for this as well. I picked my, hypervisor can actually be any, so I can support KVM, VMware, and XenServer actually simultaneously with the same primary storage. And the reason is because I'm going to tell CloudStack that this primary storage is actually just a collection of capacity and performance from my SAN, and as you spin up virtual machines, they need their root disks, their data disks. Each one of those is going to be backed by its own volume on the SolidFire cluster. So we spin up a virtual machine, maybe it has a 20 gigabyte root disk. CloudStack is going to go look at the compute offering of that virtual machine. It'll see its storage tags. It'll try to look through primary storages, find a matching primary storage. In this case, it would maybe be that top row in our table. it'll pull out the storage driver that supports that primary storage and start invoking functionality on it, like go create a 20 gigabyte volume for me. On the NFS, that would mean go create a file on the existing share. For this kind of primary storage, it means take the credentials that you used when you configured this primary storage, go off to the corresponding storage cluster, create a volume with the right size and performance, and then return the IQN, the iSCSI qualified name, to CloudStack. And then CloudStack can orchestrate the rest of this, making sure that that virtual disk makes use of that new SolidFire volume. And it happens in different ways on different hypervisor types, and that's why I have to concern myself with all of the details of the hypervisors. For KVM, as I was just talking to Guido, it's actually the easiest. I create the backend volume, and then all CloudStack does is send a message to the KVM agent to just pass in a reference to that volume, and that VM can use that volume. XenServer and VMware, it's a little bit more complicated because VMware wants to put a clustered file system, VMFS, on that volume, so we have to have a message sent to the VMware agent code to do that. This is all done automatically. And then you put a single virtual disk on that clustered file system. That works fine except for scalability issues within VMware, because VMware only permits up to, I think it's 256. We were talking about this yesterday, Ricardo. It's like 256 in pre-6 versions, and maybe 6.0 and later, it might be 512. Yeah, so you're kind of limited by the number of data stores that you can actually have in a VMware cluster. So you can see a situation where maybe some of your more expensive compute offerings would use this approach, and then maybe your less expensive compute offerings, you might have your virtual disks do the traditional approach of sharing a VMFS volume. vVols is another thing that we're kind of investigating support for in CloudStack, and that is sort of this idea of every backend volume, or every virtual disk is backed by its own backend volume, and that's just sort of something that VMware has become aware of the need for over the last few years, and they've been kind of pushing this vVols approach lately. It gives you a couple great features. You can, by having a backend volume for every virtual disk, if you have a system that supports quality of service, you can then guarantee performance to each and every virtual disk on your cloud. So it doesn't matter then how busy somebody else is one day with their workload, they're not going to impact your workload if you have the proper storage backend to support that. Other features like snapshots. Right now with snapshots in CloudStack, we call them volume snapshots. They're really more like backups. You really take a hypervisor snapshot and then you copy that to secondary storage. We call it a snapshot, but traditionally that would really be more of a backup. It's very time consuming, even if you're taking that Delta approach, which you can do with, well, probably both XenServer, maybe VMware. So with something like vVols or this kind of an approach where you have a backend volume per virtual disk, not only can you possibly guarantee quality of service if you have the right storage backend, but you can do things like fast snapshots that only snapshot that virtual disk. You don't have to take the rest of the virtual disks with you in that snapshot. Anyways, just to kind of quickly, I probably only have 5-7 minutes left. You fill in some name here. Again, we're adding primary storage to CloudStack. At the zone level, it's going to be based on the SolidFire storage plugin, which enables this kind of a mechanism that we just discussed. The protocol here in the GUI, we just call it custom. And then your provider list is a list of prepackaged storage drivers. You can actually install storage drivers after you install CloudStack, of course, just placing the right jar file in the right location. If you restart the management server, come into this dialog. If you don't see it in this list, then it wasn't discovered. So this right here is kind of the default list of storage providers that CloudStack is aware of for this particular purpose. I'll pick SolidFire. Okay, so the term, if you guys ever see this on the mailing list, managed storage, that's always meant kind of contrasted against like traditional storage in CloudStack. Traditional is where you either have a pre-allocated share and you put a bunch of virtual disks on that, or you have a pre-allocated iSCSI volume and you have a clustered file system on that, and then a bunch of virtual disks within that. That's the traditional approach. Managed here means CloudStack, if it needs to, like in the case of VMware or Xen Server, once it creates the volume through the plugin, it will do things automatically, like put a Xen Server storage repository on that in preparation for the virtual disk being placed in the file system, or if it's VMware, make the VMFS file system automatically, place the VMDK file in there automatically. So managed just means that all of those kind of details will be handled automatically. The little trick here is, for a lot of these primary storages, including mine, just by virtue of picking the SolidFire plugin, it does managed storage. So whether you check this box or not is actually irrelevant in this particular case. But if it makes you feel good, you can check the box. So capacity bytes is just, and it's kind of funny here because the GUI accepts this in bytes, not gigabytes. So if you wanted to put something in, like I typically do, something like 2 petabytes, it's just this massive number that I have in a document, I just copy and paste it. And then I put in the IOPS, something maybe 4 million IOPS. So CloudStack, what that means is, as you're spinning up virtual machines, they need virtual disks. It can automatically have back-end volumes created for you, in this case on the SolidFire system, until you hit a certain amount of capacity or performance. And once it's hit either of those limits, just like running out of space on the NFS share, you'll just receive error messages if you try to ask for the creation of another volume and there's no more space or performance. So the URL field is, I won't go into details here, this is just sort of like a collection of key value pairs. This is very vendor specific. In our case, it might be, what's the IP address that I can send management commands to for the cluster? And what we have is a virtual IP address. In our system, it's a scale-out architecture, so you just add additional nodes with extra performance and capacity. We're kind of pay-as-you-grow model. And one of those nodes is going to be hosting the management virtual IP address. Another is hosting the storage virtual IP address. And those are basically just floating IP addresses. If that node goes offline for any reason, maybe you're upgrading the system, you had to reboot it, maybe somebody tripped over the power cord, another node in the cluster will just seamlessly pick up on that IP address, either on the storage path or the data path. So my plugin just sends commands to a certain IP address, create this volume, create that account, do those kind of things, and it doesn't need to know specifically which node in the cluster is actually receiving those commands. So that's all the URL field is, maybe like the username, the password that you want to use when you send those commands. And then you just do your storage tagging like you normally would. So let's cancel out of here. I already have this one here. So now, oops, not this one here. So then I won't actually walk through the process because I don't think we have a whole lot of time, just 2 or 3 minutes. Right? Is it okay? Okay, just yell. Otherwise I have a tendency to kind of just keep on talking. So what I have here is, and I'll just kick off the process, and with VMware it takes a little while because you have that clustered file system that gets stored on the SolidFire volume, and when we clone the volume to support a new root disk, we have to change the UUID that's on that VMFS data store, and those commands through vSphere can take a little while. So let me just walk through the process here. And actually, first, before I do that, let me show you the service offering I'm using. This one here, I just have, as you'd expect, it's got a name, description. The interesting parts are, I'll highlight them, the minimum IOPS and the maximum IOPS. So this is saying the virtual disk needs a minimum of 500, in our case 4K IOPS, and a maximum of 1500 4K IOPS. And let's actually use this compute offering and see how that looks. So I'll add an instance based on a template. I'll use vSphere since I have that all set up for vSphere. I just have the one compute offering. I won't worry about data disks, but we could do that if we wanted to. And I'll just put in some name here, VM vSphere 4. And we'll let this kind of run. In the meanwhile, let me show you, for example, what another one of these VMs, there it is here, I'll highlight that. So VM VS-1, this is already a VM that I spun up maybe last night when I was using the same compute offering and the same template. And we can see how this one looks. And we'll come back to the other one when it's done. If I click on the name here, and then we take a look at its volumes, we just have a root disk, and I guess I do have a data disk. So these are both virtual disks. The one is a root disk, the one is a data disk. Each one of these will have a corresponding volume on the SolidFire cluster. So we're interested in root-5, and if I take a look at it, we can see 500 and 1500 for the min and max IOPS respectively. And if I go back to vol-123, it comes from a disk offering which we didn't take a look at, but it's similar concept where you specify the min and the max IOPS as well as the size of the volume. It's really the same thing here, 500 and 1500. So this is what we should expect when I go over to the SolidFire GUI, which I'm doing now. And I'll just hit refresh to make sure everything's up to date. All right, let me highlight this root-5 at the bottom here, this row here. So we can see that it has 500, which I don't know if you can see that, 500 minimum IOPS, 1500 maximum IOPS, and then we have this concept of burst IOPS, which I don't really probably have a lot of time to get into, but minimum is kind of what it sounds like. If you specify minimum IOPS, you will get that minimum if you're pushing the system hard enough. 1500 is kind of like rate limiting. You won't go above that unless you've accrued credits. So a lot of applications, they'll run between their min and their max. If you're ever running below your max, you're accumulating credits. And so if you do have some kind of a transaction where you temporarily need to go above, say burst above your maximum, that's when the burst kicks in. As long as the system has the free IOPS and you've earned the credits, you can burst above until you've expended those credits or until the system no longer has the available capacity to support that. So CloudStack, we wanted to kind of hide this burst IOPS concept since that's not a very standard kind of thing. Actually, I don't know if minimum is very standard either. Maximum rate limiting is something fairly common. But we just offer, you just provide the minimum and the maximum in the CloudStack GUI or the API. We will calculate the burst based on information that you provided in that URL field way back when you added the primary storage. What I've done here is I've said 1.5. Take the max, multiply it by 1.5. That's your burst IOPS. So these are all correct. We can also see here this particular volume is in a SolidFire account. So the SolidFire system is all multi-tenant oriented, just like CloudStack is. For every CloudStack account that interacts with the SolidFire system through the plugin, we will have a corresponding SolidFire account that maps to the CloudStack account that initiated the process. So in this case, I think I just have 1 or 2 different SolidFire accounts because I've only used this particular system through the plugin with probably 2 CloudStack accounts. And yeah, I think that's all of interest here. Let's go and take a look at the progress of our VM here. Okay, so it's up and running. And we can see if I just go back to the SolidFire system, refresh that. The most recent SolidFire volume is root-8. It's in the appropriate SolidFire account, which maps to our CloudStack account, and it has the right performance characteristics, as well as the right size for the SolidFire volume. And it needs to be, in the case of VMware and Zen Server, if you had like a 10 gigabyte volume for the root disk, you have to make sure the SolidFire volume is slightly larger because you have all the metadata for the VMFS file system or clustered LVM for Zen Server. And also, if you want to take hypervisor snapshots and store them within that same data store or storage repository, so we have a way of controlling that as well. KVM, it's easier because you don't have to worry about any of that kind of stuff. If the root disk is 20 gigabytes, the SolidFire volume is just 20 gigabytes. And then just to finish it up here, I'll just show you a quick little thing. on taking snapshots. So we've got our root-8, which is our root disk for the VM that we just created. If we want to take a snapshot, we'll just click on that, and I'll just say snapshot 1. Now, what's going to happen here, and I've actually got this set up in such a way with VMware. It's a little bit of an oddity with VMware. If it's KVM and you say take a snapshot, I'll just take a snapshot on the SolidFire system, and you're done. You don't have anything being copied to secondary storage, so there's not like a long delay there in taking a snapshot. Xen Server, it's also a very fast process. It takes about 1 minute with VMware, and it's because VMware has this thing around locking the VMDK files. And if you have to first of all issue a command to VMware on the hypervisor side and say, take a hypervisor snapshot of the VMDK. When you have that, you then have to wait like 30 seconds. It still has a lock on the original file. And then when you're done with that, the lock is gone and you can take a snapshot on the SolidFire side. But the same result, the snapshot, the volume snapshot, is not stored on secondary storage, it's stored on primary storage. So probably I'm out of time here, right, Charles?
You're getting close.
Okay, yeah, so if anybody has any questions about this, you can either, yeah.
What is the limit on number of volumes in a SolidFire?
Oh, it depends on how many nodes you have and how large each of the nodes are. There's at least 4 different types of nodes. You can actually mix and match the nodes in the same scale-out cluster. And so there's a calculation around based on the types and the numbers of each type that you have. So it's not a trivial question to answer right there. But if you did have a question that you wanted to ask me about that, I could run it past somebody in more detail or something. But it just depends. If it's a 3010 or versus a.
So is it hundreds, thousands, tens of thousands?
Oh yeah, it's definitely designed for massive scale. So you can run dozens and dozens and dozens of storage nodes in a single scale-out cluster. And most of the customers, they'll start with a minimum of 4 storage nodes. And that's typically a good entry point for a lot of people. They can be 4 of the larger, 4 of the smaller, in between. And then as they grow, if the newer technology comes out, maybe they've got the larger sized SSDs, they're faster, you can buy a node with those and add them into your existing cluster. And the cluster is smart enough to realize, all right, so that node is larger than these ones. That way when I load balance the data evenly across the cluster, I have to make sure proportionally there's a little bit more data on this larger node than there are on the other ones. But the data is all spread out evenly across all of the nodes in the cluster. When you add or remove nodes, it's rebalanced for you automatically. And when you connect to volumes, you do so to each of the nodes. You don't go in at a single entry point. So we load balance the iSCSI connections. If a node goes offline, it loses its iSCSI connections. You use just standard iSCSI redirect that's supported in the iSCSI initiator to talk to the virtual IP address of the storage path, and it'll load balance you out to a new node. So things like that. If you have questions about, we can go and cover all these things in more detail. I don't want to maybe slow things down, but if you have questions or anybody, just let's catch me.
Just go to the pub.
Yeah, let's go to the pub and we can talk about this all day. I love talking about this stuff, and I just don't want to take up everybody's time because I know we're kind of on a tight schedule. But all right,
cool. Thank you, Mike. And if you've got questions for Mike, you need to ask him before his 3rd drink.
I probably wouldn't even get past 1.
All right.